Thank you very much, Barbara. I want to thank everybody for sticking around throughout today. I think it was a very healthy discussion in terms of learning about what all of the different aspects of creating the digital twin of the future. In terms of Ecopia AI, I'm the vice president. We've been in operation for about 10 years using machine learning to convert optical imagery into large-scale vector-based maps using satellite and aerial imagery. Really, the main problem that our co-founders saw was there was just such an immense amount of satellite and aerial imagery that was being released on a daily basis that was just going underutilized. Even going backwards, we work with customers to be able to convert large amounts of imagery to do historical and change detection analysis. So really where we see ourselves is being able to create base maps at a very large scale using a standardized approach so that people can get to work and drive to those insights instead of having to spend a lot of time creating and digitizing maps before they can even get started. One of the things that I want to talk about today is the power of machine learning. Now, it does have its limitations, but really one of the most exciting pieces of our organization is that we can prove that we can do very precise continental mapping across the globe. One of the most exciting projects that we actually worked with was working with the Bill and Melinda Gates Foundation and also in certain countries, the World Bank, to map every building footprint, road network, and canopy layer across 51 countries of sub-Saharan Africa. And so really we want to, this has been a message that has been echoed throughout today, is being able to bridge the digital divide. And whenever you talk about the digital twin, obviously you have very precise 3D mapping, LiDAR mapping of urban environments, but also being able to scale that across very large regions so that it's not just capital cities and downtown urban environments who are being able to take advantage of the applications of the future, but being able to provide that to all of the communities across the globe. And really that's where we see ourselves, is being able to work with satellite imagery, aerial imagery, street view imagery, and convert all of that optical data into vector maps that can be used by any application available on the marketplace. And so just a quick summary. So essentially what we were doing was mapping 24 million square kilometers, and you can see some of the statistics right there. What we ended up recognizing though was we got our start working with satellite imagery, working with federal governments across the globe. But if we started to work with more precise optical imagery, there was a lot more information that we could start to pull out of that same data set. And so really where we have moved now is not just helping federal governments on very large scales, but creating right-of-way data, helping with stormwater applications, really going to that next level and pulling out other information that can help not just the public sector, but organizations like civil engineers, the insurance industry, and also the banking industry. One of the most important pieces is that especially when you're working with optical imagery and remote sensing data, remote sensing data in the optical sense, is that you can't just completely automate everything. We have an iterative approach to be able to extract and to actually reinforce the algorithms that we're using in order to be able to extract information in a more precise manner across very large scales. So we have collected tens of millions of training samples over any kind of terrain on the earth so that we can help create a base map across the globe that can be fed into the applications that organizations require. One of the more exciting things that we're doing right now is creating a 3D model of all of the United States using stereo aerial imagery. One of the first objects that we were looking at was extracting building footprints and giving all of those a geocode and address point. So we actually keep this up to date on an annual basis. We've done 3 updates of this so far, and it's being used by the insurance data industry at the moment. And so really what we're doing is trying to extract all of the buildings, all of the road networks, and all of the transportation networks across the entire country. So one of the more advanced products that we're just coming out with right now is being able to try to increase the safety of the United States in terms of pedestrian and vehicle transportation networks. So it's actually very surprising that a lot of cities don't even know where some of their basic assets are, like sidewalks. And so really what we're trying to do is create a very thorough model of the entire country to help with things like ADA compliance, and also Vision Zero initiatives. And so just keeping in mind the time here, I just, if you just give me one moment, I did want to just show you something that we created just to give you a sense of the large scale of what we're able to do in terms of our capacity. You just give me one moment. So actually, this is just this is a 3D model that we created across Taiwan and Korea within 2 weeks. And so really what our objective is to create a standardized model of basic features across the globe. And so our objective over the next 18 months is to have every major city covered during that time period. So I'll pause right there if there are any questions, but again, just want to be cognizant of time.